Alright, another draft physics video presentation. Okay, not a production, really. So, just do some comments and then comments on other stuff and whatnot, so forth. So anyway, this John Smythe guy, I think it's just a cowboy, but whatever. So you ban me because I ask for a smidgen of rigor and specifics on your theory. Yeah, you did that in one comment. In the other comments, you accused me of some kind of crime, like I have something to apologize for. Like it's a really evil for me to offer $1,700 for some physicist to give the counter argument a fair hearing, to actually respond to questions. Yeah. Ooh, what a horrible thing to do. Yeah, no, I haven't committed any crimes. I haven't lied. I haven't cheated the evidence. I haven't cheated the truth. I've sat here and said, go ahead, post a link. Post me your good physics. Show me your good physics. Show me how you have the right answer. Show me how bent space is really a complete and fully explains everything. We just, it's so obvious that it's such a great explanation, that something that's completely undefined is causing an effect. It's a completely uncaused effect, bent space. It doesn't explain anything. It doesn't offer anything. Oh, I'm some sort of criminal because I say the obvious. It's a religion. Very little facts, very little evidence, and lots of bold talk about how it's the most proven theory in the history of mankind. Just absolute nonsense. All right. Anyway, um, you know. So what do you want me to? I read your frickin' lousy, stinking, snarky comments, and I respond to them, and that's not good enough. All right. So he says I blocked him. I didn't block you. All right, so you don't have any evidence that I did that. In the video I watched it, I removed your comments. Removing isn't blocking, jackass. I read your shitty, crappy comments and I deleted them. That's what I did. You're not on my block list. So this is all just more of your bullshit, more shenanigans on your part. And all you can muster in response is word salad of. So again, you're lying some more. That's not what I did. I didn't give you any word salad. I answered every single one of your fucking questions, and I think I answered them quite completely. And so your accusation's backed up with nothing. Why don't you link me to the insufficient answer I gave you? You're just such a despicable liar. And then you say, well, why are you blocking me? What, I'm not allowed to lie? Yeah, you're not allowed to lie. Lying sucks, asshole. You can't figure that out? So you say it's too predictably funny. It's just too predictably insane that I have to sit there and waste my time. And apparently, what's 5 upvotes? You think those are honest? You really think if we interrogated you on do you really think those are real people? People different than yourself? Yeah, just some of your other personalities. So you're just wasting my view count. You're just creating fake views on the video so you can sit there and do this nonsense. So why shouldn't I block you, you asshole? Oh, too pathetic. So yes, you're blocked now. This is blocked anyway. Whatever this account is. This day-old piece of shit account. Ugh. Anyway. Academia is full of educated idiots. Yeah, well, I mean, those, it's nice words, but it's just, it's more complicated than being an idiot. They're obviously not idiots. By definition, they're educated. So, there's something else that goes fundamentally wrong. So I would argue there's something in humans. Okay, unfortunately, they're all raised on fables. They're all raised on hope and wishes. You can be the president of the United States. You can do this. You can do that. Everything's possible. They're raised on a bunch of bullshit. Okay, they're not raised on statistical data that this is your odds of getting cancer and this is your odds of this and this is your odds of that. No, you're not. You're not raised. With statistical facts. By the time you're 40, you have a 48% chance that you have some disability. Blah, 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 blah. No, you're not raised on facts. Raised on propaganda and bullshit. All right, and so that's what they'd end up doing. They can't separate themselves from the wooey crap they're fed as infants, and so they play the same game their dopey parents were playing, which is let's all just live a fake life and all be phonies and frauds and bullshitters. And they fall into the same fucking idiotic patterns. And so then they can fall for all this sci-fi little wishful thinking, Yeah. So anyway, it's all right. I'm just in the mood to get rid of all the comments, because they're all just crap. Hi, Gary. This man also claims he has answers. Who cares? I mean, where did I say I'm incredibly interested in what all the other dissidents are doing, when I've already pointed out that 99% of the dissidents are worse than the scientists by far? I mean, they're bigger liars and bigger frauds and bigger phonies and bigger fakes. Okay, so yeah, fuck the flat earthers, fuck these religious assholes trying to make science into oh yes, that's the dragons were real. It was Venus dressed in a dragon suit. I mean, it's just too fucking stupid. They're all trying to make some fun kind of other stupid fucking fantasy real. Free energy and all this other horse shit. They don't have any honest agenda. They're not trying to find the truth. They're seeking validation of some crap mommy told them. Ugh. This is just the intro video to his channel. Well, I'm just so fucking excited. So I did waste, whatever, 3 minutes of my life listening to this crap. It has nothing to do with anything I'm talking about. The guy thinks he's going to predict when the Earth is going to have its magnetic shift. Who cares? Is that a subject I give a shit about? I'm really not here to worry about some complex emergent phenomenon that takes place, weather patterns or something. You think I'm going to sit here and waste time talking about El Nino or something, or some other kind of crap that, yeah, it's real science, but fuck, it has nothing to do with fundamental science. It doesn't have to do with any of the stuff I'm talking about. So, and then he has to put a comment to his own comment. Found this in the comments. Die Hold Foundation. Very exciting. 2 months ago. That's right. You don't... why don't you watch all the video series of Polar Reversal and Ice Age and get back to me? I have a bet of $5,000 to people. They cannot prove me wrong. So if somebody says $5,000 to prove me wrong, what the fuck does that mean? We haven't proven anything. You can't even prove, beyond most people's retarded doubt, simple things like evolution. So what the fuck's the point of that kind of a challenge? Where I can't go walk into a court and say we've proven Santa Claus doesn't exist. You can't do anything rational, in terms of for money, by some standard. People, they could not prove me wrong. Wrong about what? How can you prove somebody wrong about a prediction about something that'll happen 500 years from now? I mean, it's just retarded. I obviously can't prove. I can only demonstrate with a preponderance of evidence. But I mean, again, who's going to be deciding? He's going to decide whether I proved him an asshole. So anyway, this is just a guy who's doing the whole religion thing. Okay, this is just about trying to make science fit their silly fables, and so it's just another electric universe style pile of shit, and has nothing to do with elemental physics, so it really is useless. So thanks but no thanks. What's the point? Really, unless I don't mind you showing me something that has some value, but you could figure out really pretty quickly that this guy's just talking shit, right? I mean, he's not showing you some experiment. He's not showing you any data. He's not showing you anything that means anything. So why are you wasting my time with this crap? Or the viewers of these videos with this crap? Thanks, but no thanks. Ugh, shit. Oh, well, this guy's too stupid for words, too. Are you aware that this guy supposedly has written a book called Uncovering the Missing Secrets of Magnetism? Well, how could somebody not know it if they've watched 3 of Ken Wheeler's videos? They know he's written a book, okay? So that's already a given. And the book doesn't say anything. Okay, what is this whole idea that these people think that because somebody wrote a book that it actually says something in it that could possibly mean something? There's nothing in Ken Wheeler's book he hasn't said in his videos. There really isn't. And it's just like his videos, the whole book is redundant. He just quotes the same Tesla quotes on page 2, on page 4, on page 6. I mean, you can just go through it and just hear the same shit on each fucking page. It's the book of hyperboloid and Tesla. There's nothing else in it. Ugh. So yeah, that's worth removing too. Really in the mood. Ugh. Does it help to know you're correct? Well, that you think so. Fine. Yeah, probably not. Yeah, no. What'll help is for me to get my chance to punch somebody taller than 1.5 feet high. I mean, I need something bigger to beat the shit out of, so I can just prove that I got the stuff. I win. Blah 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 blah. I need a track to run on. I mean, fuck. All right. Let's see. Thanks so much. Blah blah blah. So I already did all these. Okay. So I have got a couple of email comments that do bring up some subjects that are somewhat interesting. So maybe we'll do some of that. See if I can find something to put on the screen. Well, maybe we'll do this first. It's so irritating. Oh, the dehilsters. So, they're just so annoying just because there's no acknowledgement that, yeah, there are other people that have theories and, theirs works better than yours. It's just, they keep talking like no one did this, no one did that. Well, somebody with just gets as many views as you do has done it, so it's pretty irritating for you to sit there and pretend I don't exist. Now, you don't have to acknowledge that I exist, but it's just such a pile of crap to say that you have the exclusive rights to the particle theory model. And your model really isn't the particle model, it's the magical, whatever, moving stuff all the way down model, or whatever you want to call it, the magical speed of light squared model, or whatever. I mean, it's full of big, giant, monstrous holes. Alright, appear to be back. Cold outside. Wherever I was, who cares? So I'll just move on to, this is what I want to talk about anyway, I think. I think this is it. Yes, warp drive news, seriously. So this is, Sabine Hassenfelder, and she pretenses before her videos that, science without the gobbledygook. And then she just does a video full of gobbledygook. I mean, just, it's just such crap. And then changing, making theoretical possibility arguments, and then this whole idea of, reducing warp drive to something less than the speed of light. So you just end up making some sort of, you're warping space-time, whatever the fuck that is. So this non-existent mush of, we have these make-believe lines we drew in space, and it means the space has gotten, it's condensing, and by condensing it means it's drawing in the other space and creating some sort of perpetual energy, where we don't have to explain what happens at the singularity, at the bottom of the well. We don't have to explain how it gets the pressure gets back to the outside, the expansion happens, their wormhole, it's just all such garbage. So it's sort of worth some conversation, because this, released this, the space-time idiots have a video on, time travel. Even Sean Carroll has some little video on this again too. And it's just such crap. You're not going to go the speed of light. You're not going to go anywhere near it. It takes a real something to happen to move matter. Matter isn't just, keep pushing it, it'll go faster and faster. There's no theory for it. And it's not because Einstein says so. It's because logic can explain it to you so. So I'll do a little bit on that. I mean, I got to do a video on it anyway. specific video, a little quick video on gravity, but I just figured I'll throw in a little bit more of the general idea and why this is all such nonsense. So, I mean, there's not too many ways you can think about the universe, except, whether you think it's, well, there's no point in me saying whether you think there's spent space, because it just doesn't make any sense. You have to concede it's not an answer. It doesn't tell you why an electron is sitting someplace and, oh, there's a bent geodesic, and the bent geodesic says go that way. I mean, it's not an explanation. It doesn't. What's the form of this bent geodesic? How did the geodesic get bent? And I could do the same thing to light. If I gave you the same answer for why light bulbs radiate, you'd say that's a pile of crap. And the only difference is that you kind of intuitively have given this little extra bit of information where you know that the light bulb doesn't radiate light unless I shove a bunch of electricity into it. So you know there's some place it's coming from. But their theory is that the universe, a piece of matter, just somehow pulls the rest of the universe into it. It just pulls the universe in, and the universe goes in and in and in. There's a vacuum cleaner, and there's no output on the vacuum cleaner. So it's really some sort of magical event. Well, anyway. So we know that every single thing that happens around us, you have to have some sort of real field, a real force, a real thing to have happen for there to be, for electrons to move. They just don't move for free. They don't just move. All right, something has to affect them. Something between the objects has to be being conveyed, and we sort of know this already. We kind of know that the things are talking to each other at the speed of light. There's something moving the speed of light, and that's what's telling this where to go. And it has to wait. It has to wait for the force to get to it to tell it what to do. It has to wait for the rocks, the motivators, the things that's going to say you're obliged. So a simple theory of movement is this idea that you have to actually use some energy to cause something to go from one place in space to another place in space. It just doesn't go there for free. It requires you to act on it. It requires a force, and then somewhere another counter force says, no, you can't do that, and that's the end of the movement. That's the simple and the logic here. And you don't have this idea of moving for free. So the real point I want to get to, though, is the time thing, because it's just such a pile of crap. Warp speed isn't going to be, you're not going to go anywhere. Okay, you're just going to get to the same place quicker, and that's all you're going to do. So if you're at point A and you send you stink, right? You smell, and your smell is moving the speed of light, okay, through space. And here's point B. And you jump to point B faster than the speed of light. You're not going backwards in time. You're not making this stink go backwards. You're just saying, okay, I can go faster than my stink, and I can go to point B, and I can smell my own stink. So it's like somebody in a supersonic airplane going Mach 2 or whatever. So they're going twice as fast as the speed of sound, let's say. So they make a sound someplace, and then they fly ahead of it, and then they stop, and then they hear their own sound, and they go, wow, isn't that cool? I heard my own sound. No, it wouldn't be that cool, right? I don't even think the newspaper would write it down that, Joe heard himself say Joe, by going faster than the speed of sound. There's no event here, okay? I mean, going faster than light just means that, okay, you got somewhere very fast, and that's it. You got there very fast, so what? It's still, if it's like 10:01.64868, o'clock in the universe, all you're saying is, oh, I got someplace, and it's only, and I got there just one trillionth of a second faster than I could get there if I was going the speed of light. So what? So what if you got there twice as fast, or 100 times faster, or 1,000,000 times faster? You didn't make this clock go backwards. You just let it tick less numbers. So, at the speed of light, this number changes. And at your speed, no, it's way over here. This digit's changing. Who cares what digit's changing? It doesn't You didn't go backwards. You're just going forwards, and you can see some weird stuff. You can hear some weird sounds, but that's all you can do. You're never jumping to the past. You're only jumping to a different point, a millisecond, some trillisecond, some zillisecond later. But it's still in the future. You're never going backwards by just going fast. Doesn't all you're doing is making a second. You're just cutting the second into smaller pieces and saying I can go somewhere in a smaller piece of time. So what? You're going to the future. You're just going to a tinier piece of the future. It's a smaller bit of the future. That's it. You're even if I could show up in Alpha Centauri instantaneously because I'm moving so fast, I got there instantaneously. So what? I'm not going to be in the past. I'm going to be, if it's 10:05 here, I'm there at 10:05. I'm not going to be there at 10:04 or 10:03 or any of that crap. Anyway. So back to the speed thing. So it's Einstein's argument that if you start moving matter like an electron fast, it starts getting heavier. Okay, and it doesn't get heavier on a nice straight line where you go 10 miles an hour, you get this much heavier, and if you go 20 miles an hour, it's twice as much, and it's not some proportional kind of thing. It's this Lorentz transformation horseshit. Well, it's not all horseshit, but I mean it's pretty horseshitty. Where all of the time dilation is happening here. Nothing happens forever here, and then you do this hook at the end, and that's your chart. So you never hit the infinity, blah blah blah, and it's an endless well and all that kind of crap. And I would argue that might be part of the real game, these transformations, but I just mean this one doesn't have any explanation. There's no reasoning why your speed, doesn't have any of these effects until you get to the very, very end, where all of a sudden time starts breaking down. But anyway, the point is he's arguing that you're gaining mass with your velocity, and the mass curve would be the same kind of curve. It'd be this crazy curve. So if I go 10 miles an hour and 20 miles an hour and 30 miles, I'm not gaining much mass. But if I go a little bit faster this way, once I'm going really fast, that somehow I'm gaining tremendous amounts of mass. And so you get too heavy to push, would be his argument, right? As you're going faster, you're getting more massive. Now, the trick is if I'm looking at you, you're not going to look very massive. But you're going faster and faster, you're getting more and more invisible. So from different angles, you're very unmassive. You're running away from me. You've completely disappeared. You're so massless to me, I can't even see you. If you're going almost the speed of light away from me, I'm getting so little reflected light off of you, I can't even see you. So obviously you're getting massive in one direction, but you're not getting infinitely massive. Even if I can make the electron go the speed of light, it's not infinitely massive. So why do I need an infinite amount of energy? So, but anyway, my argument would be, is the simple argument, is that all you have to do is model the universe and say, okay, well, what if energy does something a little different? The force, the stuff moving the speed of light, has to actually hit you. And when it hits you, it stays there. As long as you're in its way, it keeps pushing you. So as long as you're in the way of a little ray of light, the little ray of light just keeps pushing. Kind of idea. It hits the electron and it keeps pushing it until either the electron moves out of the way, goes some other direction because something hits it, and it just moves out of the way, and now the force gets free again, or a counterforce hits and stops it from moving, right? I mean, that's the simple thing. So it can, on both sides of the system, you have energy. So a piece of energy is really going to say to a piece of matter, it's either going to say, I'm going to push you again, or I'm going to stop you, if I'm coming this way, or I'm going to start you as a push, So there's three modes an electron can be in. An electron could be going that way, an electron can be stopped, or an electron can go that way. But that's it. So the idea would be is that if it gets hit by more energy coming this way, so it gets hit by one piece of energy, the one piece of energy is going to roll it. It could roll at 10% of the speed of light. And then another piece hits. Well, it can do 10% again, 10% of the 90% that's left over. And so 10% of that 90% would be 9. So now I can go 19 miles an hour. And then I can do, the third one can hit, and it can be 10%. And so now I'm 28%. Well, I'm 27% because now it's 10% of the 81% that's now left over. And so now I'm only getting 8, so 9 plus 8 that's 27. So now I'm going 27 miles an hour, let's just say, or whatever the thing would be. 27% of the speed of light, if 3 things you're pushing. So you can understand that nothing can ever get to the speed of light just with this simple Model 2. Nothing gets there because you can only go as fast as the force is going. You can't go any faster than it's going because it's actually the thing causing your momentum. And so you can't add energy. So if once this thing's going really fast, how much energy is it getting hit by? Well, very little. It's disappearing. It's becoming really hard for something behind it to catch up to it. So very little energy gets to actually hit it. So you have to keep adding energy and adding energy and adding energy, because only a tiny fraction of the energy you add will actually be able to catch up to it and push it. So it's not like it got more massive. It got more transparent. It's gotten more and more invisible. The faster it's going, the more invisible it's getting. Unless I'm coming the opposite way, of course. Anyway, so that's a simple explanation. It blows up all this nonsense. We don't even have to worry about any of this stuff, because we can know that there's nothing going faster than this stuff. So how could it possibly hit something and move it? Nothing could ever get moved faster than the stuff doing the pushing. It's not possible. So anyway, I don't know. But there's never, like I said, none of these conversations happen in any kind of rational context. They all have this presumption that there's some kind of, and they always say things like the solution to the Einstein's equations. What equation? Which one? And and which one's saying what about what? And we know that the equation has built into it this idea that the closer, how to say it, it's a gimmick. In the sense of just as you're just creating something that can only affect things that are in close proximity, and they can't cause any effects far away, just because of the way the equation is drawn. And so everything always has to be hidden, because it can never leak out to any distance that we can see. But anyway, I don't want to make it even more complicated than it already is. Alright, is that all I got to say about that? Well, I guess that's all I got to say about that. Yeah, probably enough. Alright, so now we'll move on to other comments, I guess. Yeah, I'll leave that wacky crap up, I guess. So anyway, somebody else commented and asked about, so I might as well draw it. What the hell with the... So I won't read exactly what he wrote, because maybe he doesn't want me to do that, because, maybe wasn't paying too much attention to how he was phrasing things. So, but anyway, one of the questions is, one that's I've dealt with a long time ago in times of, I'll do the magnetism one first, because that's the more interesting question. So the question would be, is if you could go inside of the Earth, if you could go inside the Earth and create a little chamber inside the Earth, the idea would be is that you're in a place where the Earth has obviously absorbed some gravitational energy. And so if magnetism is, as I stated, is being created by really just taking gravity and filtering it, and therefore making it possible for the magnets to take advantage of the force, because I don't know how to put it. The red is doing, obviously, if there's two forces and they're contrary, they're negating each other's effect. So if you segregate those two forces, then obviously you magnify their effect, because you've taken away the negative element. So it's like thinking about the whole universe as having force equalization. So you can't see that. So there's as much stuff going this way, as there is stuff going the opposite way, going this way. And if I could possibly take all the stuff that's going the opposite way, the yang out, and all you had was the yin one way, how fast would you end up going? If you could imagine the whole universe, I could take all the energy that's moving this way, hitting me away, And also all that was left is the stuff going this way. How fast would I go? And I could argue, well, you probably would go the speed of light. And so how fast do you go on the surface of the Earth? So when you're on the surface of the Earth, how much gravity, how much of the force are you appreciating? Well, 22 miles an hour, right? I mean, it comes out to like 22 miles an hour is how fast gravity's pushing you. 22 miles an hour versus the speed of light. I mean, that's a pretty lame amount, right? That's a tiny percentage of the gravity the whole Earth has used up. So the whole Earth, I could just draw it like this, sort of. The idea would be is you can sort of understand that it's this whole diameter of the Earth, all right, that you're standing on. You're not even standing on the radius. You're standing on the whole diameter of the Earth on one side, and that's the side blocking the energy, and the other side's the side that's not blocking it, and that's sort of the theory. But it's a tiny amount, right? And even on the surface of the sun, you've only got 7 times as much gravity, so you're going 110 miles an hour or whatever. Not much, it's not very impressive. So the idea would be as if I could get inside the Earth, if I was, and so I could have a magnet inside the Earth, and where theoretically some of the force from both directions has been used up, well, from all directions, but it doesn't really matter. That the magnets would be less, they'd stick to each other with less force. Well, if it's true, that all you're using up is 1/10,000,000th or 10 trillionth of the actual force. The 22 miles an hour represents a tiny fraction, and inside here it's a lot less because now you don't have the whole diameter absorbing the force. So there's going to be you don't have as much of a differential. You haven't used as much of the gravity, so to speak. Because you're only going at this distance rather than the whole diameter. And so it's a tiny fraction. So you could argue that it does have an effect, but the effect is so tiny. And this just goes back to the fact that we know that charge, or magnetism, is 10 to the 40th times stronger a force than gravity. So there's a huge gravitational potential. There's potential for a tremendous amount of gravity to be caused. So there's it's just too tiny an amount. So the Earth is theoretically blocking very little of the actual energy, and this goes back to the simple argument that the atom is mostly empty space, and also that you're not moving electrons very far. When you move them, you're not moving them much. So when your force has going the speed of light, it moves an electron of this distance. It's not absorbing much energy. I mean, the amount of energy being absorbed is minuscule in terms of the tiny amount of shift in the progress of this force, the tiny amount that it lost from its speed at the speed of light is so tiny, that it just doesn't, you need an awful lot of it to create any real effect. But anyway, it's a legitimate question. I guess my answer would be yes, but you also have to consider that if you go inside the Earth, you have all this tremendous chemical pressure. I mean, to be able to build a place to live inside the Earth, you'd have to have this insanely strong structure, to be able to take the pressure that would be all the chemistry pressure, the chemical pressure, the molecular pressure, I guess is the way to say it, the atoms pushing down on you. It's all of this weight, at the force of gravity is all this huge mass that you've got to stop from moving, or try to, that you have to provide a counter force. So you're really saying, I'm going to use this mass moving to stop this mass from moving, and you have to do it through some kind of structure like a steel girder or something. So all of that tremendous amount of torque has to go through whatever structure you're building, and you're not likely to be able to build anything that can even take the amount of pressure that you're forced to make a container for. It's so much pressure, per square inch or whatever. It would be a tremendous amount of pressure you'd have to be able to hold back. And while you're holding it back, that piece of steel or whatever probably would be radiating an awful lot of energy because of the stresses it's under, and so that would compensate for the lack of gravity anyway. Perhaps. I'm not saying that's the way it is. I'm just saying there can be a counter argument that you can't really stop it. You're just converting the energy. You're converting something moving the speed of light into some matter bit moving some other speed, but it just doesn't matter because it's still movement, and you still have to counter the movement with something. And the movement just means that you're moving electrons closer to electrons, which is the same thing as adding force because they're bouncing off of each other and all that crap. So it wouldn't matter. All right, the other issue you brought up was electrical and, conductors. And so you have a wire, and the wire goes plus, minus. So I move a magnet in, north side of a magnet, and the wire creates a current, okay? And it creates a charge differential is what it's creating, but regardless. And as I've pointed out, you really have to move the magnet a certain speed. So there is like a speed of sound and a speed of light and a speed of all this other stuff. There's a speed of induction. If you don't move the magnet fast enough, you won't create any electrical potential. So the faster you move it, all right, faster equals more. All right, so you'll have more effect the faster you can move that magnet. The faster I move it, the higher the voltage potential I'll create. So it's an integral part of the whole function, is that what this is doing is actually pushing force. So the faster I do it, the more reflections there are. So it's like this piece of chalk. If I could move it really fast, it'll take all the energy between me and this Newton point, right? So I'm going from point A to point B. Point A to point B, okay? And that has a certain dimension. And if I move it fast, really fast, the speed of light, that means I would collect everything in this whole big square and I would put it in this little tiny square, right? I'd compress all of this energy, every little bit moving in this pile of energy, I would put in this little block. That's how it would end up working. So if I can move something fast enough, I'm compressing the energy. I'm taking energy that's spread over a large area, and I'm pushing it all at once. And so that's what the magnet's doing, the same thing. It's collecting all the energy here, 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 as you're moving it, and pushing it all into this space here. And the point is that there's going to be a reaction. These electrons are going to move away from that extra energy. And the point is they can't move away fast enough to spread the pressure. And that's why they have to move it this way. So it's almost like the ocean argument, that when you push into the water this way, it's uncompressible. It pushes up because that's the only direction it can go. And then gravity pushes back down, and that pushes the wave forward, and it just keeps doing the same thing over and over again. Same idea, sort of. The conductor can spread the imbalance, but it can't spread it faster than its atoms will allow it to spread it. So if you move faster than the atoms can dissipate it, then you will force there to be a charge potential. Now once you've charged it, once you've moved the magnet in, so DC current does work in terms of creating electricity, but it only works once. It only works when you're moving it in. So if I take another magnet and I do the same thing down here, I can create more voltage. So if I take another magnet and so this one I moved in, I created a potential across the wire. It's there until I release it. It stays there. Now if I move another magnet in, well, then I can add to that potential. So I can go from 50 volts to 100 volts, by moving another magnet in. But that's all I get. So if I drain it, that's all I have is that 100 volts. And what I also don't have is I don't have any way to push more with this magnet. I've already pushed. I'm done. So until I relax it and I move it back away again, and if I move it quickly away, I'm going to do exactly the opposite, just create an opposite current, opposite direction. So if I move it away quickly, I'm going to do the exact opposite. I'm going to pull them too quickly. All right, and I'm going to end up with the same voltage potential. I'm going to pull them too quickly off the surface, and I'm going to get exactly the same action in reverse. But if I moved it slowly away, then nothing's going to happen. You're not going to move it in fast again and cause the same pressure. But you really, once you cause the pressure, you've used up what you created. And until you reset the system, until you compress the spring again, the spring can't fire. So it's really just about firing. And you can fire either direction is the key. So, yeah, so I mean, the reason why you have to have alternating is kind of obvious, in the sense that you have to pull the trigger back again. You have to reset the gun. You can't just fire the gun and then keep firing the gun. Something has to reset it. All right, so and obviously a gun's doing that because it's taking some of the velocity off of the bullet, to pull the trigger back. So, but if you didn't steal the energy from the bullet, there wouldn't be any energy for pulling the magnet back, so you have to provide that. So that's why alternating current works and DC doesn't, is because obviously the alternating current, just switching the direction, ensures that you keep recharging the system. So now you're just moving electrons back and forth, back and forth, back and forth, back and forth. Which works in terms of the back and forth motion. You're just sending it through the wire and creating back and forth motion at the other end. And through the space of the magnets, you're turning one magnet on, okay, and then that's inducing in the other coil, and then that induces in this one. It's the whole induction thing, back and forth. I probably could explain that better, but oh, hell with it. Alright, so I did that. What else? Is there anything else I have to deal with here? Yeah, sorry, I'm just losing all give a damn. But it's just wrong attitude. Alright, let me pause and see if there's something else. Oh yeah, I already remember. Ultraviolet catastrophe. So this is another weird one. It just has to do with the fact that they had a wrong idea, and it made predictions that just weren't true, because it goes sort of to de Broglie and this idea that they associate the energy with frequency, and that's just a mistake, because it's only circumstantial, right? So the idea is that ultraviolet light has a certain distance between the nodes of the wave, you could argue, however, to make it compatible with a particle theory. And the simple argument is the infrared, or the red light, would be much further spaced. And so they're sort of trying to argue originally that this has more energy. Well, it's still just three blobs of stuff, and this is just three blobs of stuff, but they were saying this can do so much more, and so it's more wattage. And so this, I don't even know if I want to get into the whole way they try to calculate this stuff, but it has to do with temperature. So as you increase temperature, there was this expectation that it's just as easy to make this as it is to make this. And that this is before, I think, they either also recognized that this infrared energy and this blue energy has a completely different profile in terms of how it hits a surface. So its radiance is completely different, in the sense that the red light has big polarization. So when it hits a surface, it hits, say, this much surface. This is red light. The amount of surface the red light has to hit. The amount of surface the blue light hits is half of that. So you can sort of understand that if I was to measure its radiance, and I didn't compensate for the fact that the blue light's hitting a much smaller area, I might not appreciate, the fact that it's really the same amount of energy. It's just one is going to hit a smaller amount of matter. It's going to affect a smaller number of electrons. So obviously it's going to have more effect per density. Okay, so if I have 10 electrons in here and I have 100 electrons here, you can sort of understand that the red light is going to have per electron a lot less effect than the blue light, which is guaranteed to, say, move 5 of these, half of them. So it look like 1/2 of the electrons are affected by blue light, and it look like only 1/100 of the electrons are affected by red light. It'll look completely disproportional because I'm not appreciating that when I'm measuring this radiance, that the surface that the light falls on is much smaller because of the polarization. Now the other fact is that there's just no recognition that atoms can only produce so much because their orbits are limited, in terms of how much energy they can actually produce and how much frequency they can produce. How fast they can actually move an electron from one place to another will decide how big a frequency they can make. So if they can only go a certain speed, if they have a speed limit, well then obviously they're going to have a real hard time making high frequency light. So there wouldn't be any expectation that this light is as easily created as the red light, because the atoms just don't do that. So that was another part of it. So they sort of argue, well anyway, they just fixed the formula and they gave different people credit for it. But I mean, it's just they had the wrong formula. They didn't, they had the wrong formula. So clearly there was no catastrophe, except they didn't understand that you can't generate more. It's almost like the old formula had this bit in it where it was creating almost free energy, you could argue. I don't know, it was so far off that I don't even know why they thought it was the right formula in the first place, because technically it doesn't even get the equation. I mean, technically, you could say the charts were going like this. Well, I mean like this. It was already off here. It just got insanely off here. Where this goes this way, their chart was going straight up. But, I don't even know. But yeah, it's way too complicated to explain, just because they put it in all these weird terms. Like I said, they're measuring the energy in joules, and then in watts, and then in some other spherical thing or something, how much energy per square meter at a certain time, and then you have to average the distance of the circle. And I mean, it's just too complicated to explain. But that's really what it's all about. It's just that the units were off, and so there wasn't any, there's nothing miraculous. There's a certain amount of heat that you can produce, because there's a certain limit to how much real distance you can move at a real speed, I guess is what I'm saying. You can't, now it's no point in me saying that if I increase this speed infinitely, I mean, you could argue, there's no such thing as an infinite speed, because then I'm going in a finite distance. I mean, I can't jiggle at an infinite speed, because to do that I'd have to move a smaller and smaller distance, and so I run out of distance as I increase how fast I'm moving, if you get my drift. I can't do both. I can't keep either one constant. So as I increase the speed of the jiggle, I decrease the distance the jiggle can move. So if you're assuming that it's all jiggling, it's all moving the same distance, I guess that's a good way to analogize it. They were sort of assuming that no matter what jiggle I have, I move the same distance. So obviously, the big stuff looks a lot bigger than it really is. Well, the little stuff ends up looking huge because it's going fast this bigger distance. But it was really only going fast this little tiny distance. So that's sort of a way of understanding. If you got that wrong and you thought the fast stuff was jiggling this big distance, then you would think that would have a huge amount of energy compared to its reality if it's really just jiggling this little tiny distance. So the higher the frequency, the smaller the amount of movement. And so that's what's compensating for the inequality that they were seeing in their prediction. That might be a better way to say it. Might be. All right. So now I'll take a break. Try again. See if there's anything other worth summarizing. All right. I thought of something else. I mean, just part of the stuff that kind of makes it funny to have, just conceptually thinking about things. And technically, if I could move this piece of chalk faster than the speed of light, the catch would be not only would it collect, so the argument is this simple argument, right? So I have an object and I move it into a field of energy, randomly moving energy moving in all directions. And I move it into that energy. The idea is to collect all the energy, okay? Like say if some little bit is going this way and it's here. Well, it hits and it moves the speed of light away, and so it's going the same speed as the object. And then if it hits one here, it reflects and it's going the same speed as the object, so it would collect every piece of energy. So all the energy in here would be collected by the object, and so now also everything in this space would be now in front of the object. So all the energy that was collected here would be in front of the object. Now if I'm going faster than the speed of light, it gets even more ridiculous, in a sense, because nothing can ever escape, right? I mean, I'm moving faster than the speed of light, so I'm going to collect every single bit, and it's never going to be able to reflect at all. I mean, it's not even going to be able to be a little bit tied with me. It's going to be so thin a line. The line's just going to get thinner and thinner. So you're taking energy in this huge space and you're putting it into a little tiny thin line that's just getting thinner and thinner and thinner the faster you go than the speed of light. And whenever you stop, or even slow down a little bit, all of that energy is now going to be free to go. Okay, it's free to reflect, do its normal reflection. And so wherever you arrive, you'll essentially blow them to bits because you will have stored so much energy. So your whole trip across space, so if you're going the speed of light across space and you go into Alpha Centauri, just remember you've collected all of the energy between you and Alpha Centauri. You just collected it all, right? Every bit that your object has a capacity to absorb. So you collected every single bit of that energy, put it in a little tiny box right in front of you, and now as soon as you step on the brakes to slow down, all of that energy is going to just fly right into whatever you're trying to land on, and it's going to blow it into a million little pieces. So that would be one of the little ironies of your warp drive, is that wherever destination you were planning on, whatever holiday resort you were planning to fly to at warp speed, you're going to blow the shit out of it as soon as you try to land there. Anyway, just pointing out that their theory doesn't have energy in it. Their theory doesn't have any real force in it. I mean, just kind of quit saying that this makes any sense to have a conversation about reality when your premises are bent space is some sort of real thing, time is a dimension when it's not perpendicular to any of the other three dimensions. It's not a dimension. It's just silly talk. And virtual photons, are controlling all the quantum mechanical effects. I mean, the whole thing is overtly mush. So you're not going to have any realistic conversations about realistic physics and what can really happen, what's really possible. Just not. There's a real consequence to going fast. That's the simple argument, and you can sort of figure that out, right? There's a real consequence to me moving fast. You could even understand if you lived in a really foggy place. Let's say you live somewhere that's really foggy. Okay, so those are water molecules. You can kind of think, well, what if I went really fast into those water molecules, right? And they all, they're going to stick to me, sort of, right? And I'm going to collect all of that water. And if I went miles and miles and miles through the fog really fast, you can sort of understand I'm going to collect pounds and pounds and pounds of water. And the water's going to be going really fast like me. And so as soon as I put a brake pedal on, what's going to happen to all that water? It's yours. It's going to be the arrival fee. So you'll be having your hand out waving. Oh, look, they're coming to see us at very fast speed through the dense fog. And they're going to hit you with a big wall of fog. You can get this. That's the real physics. Right? The real physics is you're not going to do any of this crap they're daydreaming about. It's never going to happen. Mankind, nothing. A rock, an electron is just not going to break the speed barrier. It's not going faster than the speed of light. And if it does, it's going to be a menace. It's going to create all kinds of problems. All right. Till the next, and the longer it travels, faster than this, the further it goes at the speed of light, the more of a menace it's going to be. Anyway, yeah, that's enough. So, till the next time and such. It's just so depressing, these conversations. Okay. Till next time and such.